Hello. So in our last lesson, we went over how to factor simple quadratic equations. So in today's lesson, our learning target is the same. It's still I can factor quadratic equations by trial and error, except this time we're going to do much more complex quadratic equations. So standard form for a quadratic equation, as we went over, is ax squared plus bx plus c is equal to 0. So thus far we've been doing quadratic equations where a, our leading coefficient, is equal to 0. So say like x squared plus 4x plus 4 is equal to 0, for example. And the nice thing about these equations is we can always set them up by having x plus or minus m times x plus or minus n is equal to 0. Essentially, we always know that we're just going to have our first term of each of these expressions is just an x. So now we're going to go into quadratic equations where a is not necessarily equal to 1. So that makes things a little bit trickier. So let's start out with an example. Let's do 2x squared minus 14x, let's say plus 24 is equal to 0. So note now that we have a leading coefficient of 2. So what this means is that we can't just immediately say, okay, we know we're going to have x plus or minus something times x plus or minus something else. But there is one thing you'll notice about this equation, which is that look at each of these terms. Each of these terms is divisible by 2. So what that means is that we can factor out or pull out a 2. So this is a really important skill that you're going to use kind of for the rest of your life in mathematics. And what we're going to do is say, okay, I'm going to pull out a 2 from this term. So we're going to have 2 times x squared. We're going to pull out a 2 from this term too. So negative 14 divided by 2 is negative 7 minus 7x. And we're going to pull out a 2 from this term. So we're going to get a plus 12 is equal to 0. Now we have a 2 multiplied by an expression with a leading coefficient of 1. And this expression we know is much easier to factor. So this is going to become 2 times x plus or minus something times x plus or minus something is equal to 0. And we'll go through our same old process for factoring. So let's open up a window on the desktop. Notice that we have a negative 7 here, so we have a negative term here and a positive here. So if you recall our last lesson, that means that we have to be multiplying 2 negative numbers together to get negative 12. So we could have negative 1 times negative 12. We could have negative 2 times negative 6. Or we could have negative 3 times negative 4. So there are possibilities. Recall that our numbers also have to add to equal negative 7. So we can eliminate these two. Negative 3 plus negative 4 is equal to negative 7. So that's our answer. So now we've factored this equation as far as we can. Now to find our solutions to the equation, we can do something cool. We can divide each side by 2, and these 2's will each cancel, and 0 divided by 2 is still equal to 0. So we'll get x minus 3 times x minus 4 is equal to 0. And using the zero product property, our solutions are just x is equal to 3, x is equal to 4. and that is our answer to this equation. So that covers how you factor an equation by pulling out a constant. Again, here, we pulled out a 2 from this equation, and the reason we could do that was because each term in our quadratic equation happened to be divisible by 2. So now let's look at another example of a problem like that. Let's do 6x squared plus 21x plus 18 is equal to 0. So now our leading coefficient is a 6. So what we're going to do is we're going to say, okay, I'm going to look at each of these terms and see if they're divisible by the same number. So are they each divisible by, we can start with numbers that 6 are divisible by, since that's our smallest number. So is 6 divisible by 2? Yes. Is 21 divisible by 2? No. So 2 is not going to work. Is 6 divisible by 3? Yes. Is 21 divisible by 3? Yes. Is 18 divisible by 3? Yes. So what that means is we can do what we did here. We can pull out a 3 from this. So that will make this equation equal to 3 times 2x squared. That's again, since 6 divided by 3 is 2. 21 divided by 3 is 7. And then 18 divided by 3 is equal to 6. So now we want to look at this again. So unfortunately, our new expression here still has a non-zero leading coefficient, or a non-1 leading coefficient, sorry. So what that means is that we're going to have 3, and we're going to be multiplying it by 2 terms, but each of these expressions is not going to just have an x, a single x like it is here. Because in this case, we need the first terms to multiply to 2x squared. So if we try to put an x and an x in there, and we multiply each of those together, we're not going to get a 2x squared. We're just going to get a single x squared. So what that means is one of these is going to have to equal to 2x. Because now we have 2x times x is equal to 2x squared, which makes us happy. Here's where things get a little bit tricky. So our last terms still do need to multiply to positive 6. So I'm going to open up another window on the desktop, and we're going to find all of our pairings that multiply to 6. So we have 2 possibilities. Although actually, now since these are not symmetric, since these are different, we do have to do the reverse directions as well. So once you get to this point, there's no kind of quick and easy way to figure out what combination you have to use, which is unfortunate. We kind of just have to play around with these combinations and see which one will work, so that if we FOIL this out, we'll get our original quadratic expression. So if you do enough of these, you'll kind of develop an intuition for realizing which combination of numbers is going to work really well. So to start out, let's just try all of them. So if we have 6 and 1, we're going to get, for our middle terms, we're going to get plus 2x plus 6x plus 6. 2x plus 6x is equal to 8x. That makes us unhappy. I'm going to cross out that option, and I'm going to cross out this. Now let's try flipping them around. So what if we have 1 and 6? This time, we know we're going to get these as our first and last terms, so I'm only going to focus on the middle terms. We're going to get 12x plus x, which is equal to 13x. That is incorrect, so I can cross this guy off the list. Next, we're going to have 2 and 3. So if we have a 2 and a 3, we're going to get 6x plus 2x, which is equal to 8x, which again makes us unhappy. So we'll cross this one off the list. Now we only have one combo left, which is 3 and 2. So let's try it. 3 times 2. Well, we really hope it would work since it's our only one left. We're going to get 2x squared plus 4x plus 3x plus 6 is equal to 0. That will give us 2x squared plus 7x plus 6 is equal to 0. And bingo, that's what we wanted. So 3 times 2 is our winner. So what that means is now, if we want to find the solutions to this equation, we can divide each side by 3, and then we'll get 2x plus 3 times x plus 2 is equal to 0. And if we multiply and if we look for use the zero product property, we get 2x plus 3 is equal to 0, 2x is equal to negative 3, and we'll get x is equal to negative 3 halves. Over here, we'll simply have x is equal to negative 2, and these are our two answers. So as you can see, this is quite a bit more complicated than the simpler factoring problems that we've been doing earlier. So I wanted to do one more example of a problem like this. So let's do 4x squared plus 29x plus 30 is equal to 0. So this problem looks extremely daunting at first glance. 29 is a prime number, so we can't divide this quadratic equation by anything to make it a little bit simpler. So, and additionally, we have two options for our first term pairings, because we need our first terms to multiply to 4x squared. So our options are we could have either 4x and 1x, or we could potentially have 2x times 2x. So this is looking really grim, because in addition to having combinations that multiply to positive 30, we also have to try them out in both of these orientations. So let's open up another window on the desktop. It's going to be a big one. So we're going to have 1 and 30. We're going to have 30 and 1. We're going to have 2 times 15, 15 times 2, 3 times 10, 10 times 3, and then we're going to have 5 times 6, and 6 times 5. So this is going to be a fairly long and drawn out process, because let's see, we have 1, 2, 3, 4, 5, 6, 7, we have 8 options. And each option we have to try in both of these formats. So 8 times 2, that means we have 16 possibilities. And unfortunately, as I mentioned before, there's not really a quick and easy way to figure out which is the best one. We just kind of have to try them out and see what works. So we're going to need the middle terms to sum to 29. So first let's try 1 and 30. If we do 1 and 30, we'll get, for our middle terms, we'll get, this is going to be huge because we're going to get a 120x plus 1x, so it's not going to work in that one. In this one, we're again going to get a 60x plus 2x, 62x, so we can take that one off the table. In this one, we don't need to try out both directions of the multiplication since they're both being multiplied by the same thing. So we don't have to test that one in this one. So I guess I can subtract 4 possibilities. So there's actually only 12 possibilities, if that makes us feel better. If we put a 30 here and a 1 here, we're going to get 4x plus 30x, which is equal to 34x. So we can eliminate both of these. So now I'm going to look, and let's think about this for a little while. We want 2 things that are going to sum to 29x. So I could keep going through each of these and trying out each of them using the pure trial and error method. However, I could also say, I'm going to lock in on these 2. I can say, look, if I have 4x times 6, that's going to be equal to 24. And then if I have 5 times x, 1x, that's going to be equal to 5. So you know what? If I put the 6 here and a 5 here, our first term is going to be equal to 4x squared. Our second term is going to be equal to 24x. Our third term is going to be equal to 5x. And our last term is going to be equal to 30. So what that means is we have 4x squared plus 29x plus 30, which is exactly what we were looking for. So it turns out that 5 and 6 in this equation is our winning combo. So then if we were to go further and solve this equation, we'd get 4x plus 5 is equal to 0. So we'd get 4x is equal to negative 5, and x is equal to negative 5 over 4. Or we could get x plus 6 is equal to 0, and then x is equal to negative 6. So those would be our 2 possibilities there. And that concludes our lesson on solving more complicated factoring problems for quadratic equations. So in our next video, we're going to go over recognizing the sum and difference of squares and how we can use those to solve quadratic equations.